So I decided to say that there are x 10p's, y 20p's, and z 50p's. There are 20 coins in total, so x plus y plus z must equal 20. And the total value is 50, so the value of the 10p coins is going to be 10x. It's the number of 10p coins times 10. Similar for the 20p coins, 20y, and then 50z. And that's going to equal 500. We can divide through by 10 to give x plus 2y plus 5z is equal to 50. Well, I have kind of got simultaneous equations here, but I've also got the fact that x and y have to be whole numbers. So the first thing, and oh, we're also told, sorry, there are more 50p than 10p coins. So z is greater than x. That's another condition to just be aware of. So what I can do actually is take the two equations and subtract them. There's other ways to do it, but basically I can eliminate one of the unknowns. So if I subtract them like this, the x's cancel, some of the y's cancel, I'm left with y plus 4z is equal to 30. And this is a Diophantine equation, integer solutions. So one thing I can do actually is divide through by 2. A half y plus 2z is equal to 15. So I know for sure that y is going to be a multiple of 2. And at this point, I'm just going to try numbers out, remembering that z has to be greater than x. So actually, I think I want to, yeah, y and z are my focus, but I also need to find x along the way as well. So first up, what about y equal to 2? Then this would become 1, and therefore z would be 7. And remember, the total is 20, so x would be 11. I can reject that one then, because z is not greater than x. Let's go up to 4. But now I would have 2 here, and then z would not be a whole number. So I can reject that one straight away. And actually, I just need to go up by 4 each time. The next one would be 10. So if y is 6, I'll get 3 here, and z is then going to be 6. That gets me to 12, so x is 8, still bigger than z. 10 is going to give me z is 5 and x is 5. Okay, now they're equal. We're nearly there. So I think it's going to be the next one. 14. Therefore, I'm going to get 7, so I'm going to get 8, I'm going to get 4. And then x is going to be 2. Let's just check the next one. I imagine it's not going to work out, so this seems to work. If I go with y is 18, I'm going to get 9 here. Z is going to be 3. That's not going to work because I'm already over the limits. X would actually equal to -1 for this to work. So this must be the solution. How many of each type of coin do I have? 14 10p's, 4 20p's, and 2 50p's. Okay, in the real thing, I'd probably just do a little bit of explanation on this table, just explaining actually that it's a Diophantine equation and I must have y as a multiple of 2, but it can't be a multiple of 4 as well because that would make a half y even. And just carefully working through them until you get to x being a negative, and from then on x will be negative. So there's no other solutions, it must be this one here.